यस सर।
चलो ठीक है, मैं लेक्चर स्टार्ट करता हूँ। ठीक है अभी।
यस सर।
Bismillahirrahmanirrahim. Dear students, inshallah today we will solve the example related with the roof sheeting design. So we are provided with this data. So in the information, what we're supposed to do, design a 75 into 20 GI corrugated sheet. GI mean galvanized iron corrugated sheet with this designation. So 75 is the nominal pitch and 20 is the nominal depth of that corrugated sheet. And sheet for the roof truss with following data, and assume dead load of roofing system is provided as a 17 kilogram per meter square. So if it is not given, you can assume any appropriate value for the roof sheeting load. So how you may assume this value for your own design? For example, you are provided with these tables. For example, this table. So in this table, you are having this table also in your LRFD manual. So you are having the standard weight of various uh, sheet with various thickness or the gauge value. So you can assume any weight appropriate from this sheet. So the maximum weight is for gauge to 12 sheet, and the minimum weight is for the gauge 29. So lesser will be the gauge number, more will be the thickness of this sheet. So actually based upon the market, maybe you have to check that in the market what gauge of the sheets are available, then you can assume their weights accordingly. So for example, you don't need to assume maybe the weight of the lowest gauge sheet, which is 250.6. So from here you can they assume the approximate weight or the weight at the for the start or for the start of the calculation, maybe for gauge 20 or gauge 18 or maybe gauge 16. So for gauge 18, so the weight is 119.3 Newton per meter square. So if you are dividing this value by 9.81, so you can convert into uh, kilogram. So in kilogram, I believe this weight is around 12, maybe 12 kilogram per meter square. So anyhow, you can assume the weight of any appropriate sheet from this table, or any weight value between maybe 39.8 to 250.6 Newton per meter square. But I will recommend you to assume the weight ranging between gauge 24 to gauge maybe 12. So in our data, maybe we are assuming the value maybe 17. 17. So 17 mean that if I multiply with the G value maybe 10, so that would be around maybe 160 Newton per meter square. 160 mean that that is the weight between gauge 14 and gauge 16 sheet. Or you can assume the weight corresponding to gauge 16. But later on, if the design is coming for gauge 14, so you can revise the calculation. So at the start, you can assume the weight for any higher side. So this data is provided to you, but I have already provided you the data for your design classes or design project. So the cell weight of roof sheeting system is given to you already. So here in this example, we are considering as a 17 kilogram per meter square. So if you are considering G value 10, so this weight will be around 170 kilogram Newton per meter square. The insulation panels are not attached. So we are not attaching any insulation panel, only providing the corrugated sheet, just like maybe in parking shed or in any industrial building. So in industrial building, you might have seen that only the roof sheeting is directly attached with truss system without the insulation panel. But if this building belongs to the residential building, so insulation panels they are also attached with roof sheeting. So here we are not considering the load of any insulation panel. So total miscellaneous load is given as a 5 kilogram per meter square. So miscellaneous load means the load of all the nuts, bolt, washers, and clamps, cleat angle that we are using to make the connection. That will be used for the entire roofing system. But for this design problem, so we are considering some portion of the miscellaneous load only. So live load, it may not be given to you. So you have to assume the, or you have to take the live load based upon the inclination of roofing system. So we have already seen that if inclination of our truss is 30 or more than 30, then the live load or snow load will be 60 kilogram per meter square or 600 Newton per meter square. So further, panel length is 2.5 and spacing of truss is 5.5. So spacing of truss is also equal to the length of the purlin. So the panel mean that what is the horizontal distance between two panel points or two consecutive joint with reference to the top chord. So truss is having total 8 panels. So if the length of one panel is 2.5, so the length of total truss will be 8 multiplied by 2.5 and answer will be maybe 20 meter. And there are total 20 trusses. So in lateral direction, length of the building is equal to length of truss and the width is equal to the 5.5 multiplied by 9 because we are having 9 trusses in our building plan. Sheet projection beyond the center of truss support is 300 millimeter. So what this sheet projection? So sheet projection last time I have explained. So at the edge, for example, this is the last purlin which is at the support. So a sheet is further extended to this beyond this support, whose length is given as a 300 millimeter. I will see maybe we are having some truss or not. Last time I sketched. So if we are providing the sheet, so sheet is further extended beyond this support by a distance of 300 millimeter. Based upon this data, so first of all, we need to compute how much total load is acting on our roofing system. So please note that we are using ASD method, allowable stress design. In allowable stress design, we are only considering the service load. We are not multiplying all load with any factor of safety. So here, this 16, so actually here there is a mistake in my calculation. So here I have considered this load as a 16 instead of 17. So I supposed to use this load as a 17. But anyhow, I will modify my calculation and I will make this load as a 16. Because here I have written the dead load as a 17, but I am using in my calculation as a 16. So I will change it. So 60 is the live load plus 5 is the miscellaneous load. So I'm only considering the 1/3 of miscellaneous load. Just like in purlin, we are considering half load of miscellaneous load. Miscellaneous means total clamp, washers, nuts, and bolts. So actually, this miscellaneous load is for the entire truss system. So a lot of connection, bolts and washers and others are provided with the truss. So maybe we are using only partial bolts or the washers to connect the roof sheeting with the purlin. So miscellaneous load which is acting on our steel sheets will be maybe 1/3 or 1/3 to the half of miscellaneous load. So all type of the load will be added up because we are using ASD method. So we are not multiplying the dead load with 1.2 and live load with 1.6. We will just reduce the material strength by factor of safety, or we are using the allowable stress only. So total load, service load which is acting, we are multiplying the total load with 9.81 to convert into Newton per meter square. So total load is Newton per meter square. So, but we need to convert this load as a UDL load. So UDL load means that last time I have also explained that we are assuming we will design the roof sheet as a beam which will have a unit width. For example, just like here, we will assume that, for example, this is a sheet and each sheet panel is having total width 1 meter, although it may have any width, and it is supported between one panel to the other purlin. It is supported on one purlin on the one side and a purlin on the other side. And we need to consider because load is acting in downward gravity direction. So the span of this truss will be equal to horizontal distance between this panel point and this panel point, which is equal to panel length. And we are assuming that this beam is having unit width. So on this sheet, we are having the load acting per unit area. The total load is which is acting on this area. Area means that on this width and on this length. So if I will multiply the load acting per unit area by this width, so I'm converting this load into UDL load, which is uniformly distributed along this length. So I believe that last time I have explained it to you. So we are assuming that our roof sheet is simply supported between two panel points, and we just need to consider the horizontal distance because load is acting in the gravity direction. So we will convert the load into the UDL load because this is load acting per unit area. So we are considering that total width of the sheet will be equal to unit. Unit means 1 meter. So if I multiply 762 into 1 meter, so 1 meter will be cancelled out with the meter square in the denominator. So we are having a UDL load acting on a roof sheet. So we are assuming that the roof sheet is the beam whose width is equal to 1 meter and total UDL load on this sheet is acting as a 762 Newton per meter. Okay, now next is that we will select that what is the sheet, the size of the sheet panel. Size of the sheet panel, actually we just need to compute the length. So I told you that in market, if I will show you this table again. So for all type of the sheet, width is constant. So sheets width is constant. We cannot decrease or increase this width. So the maximum width of the sheet which is available in the market is 0.7 meter or 700 millimeter. And after subtracting the covers or end lap, effective effective area covered by one sheet will be 585 millimeters for GI 75 into 20. So it means that we already know the width, but we know that how much length is required. For example, I show not here. Okay, maybe here. So actually we know the width of the one sheet, which is zero point 0.7. So we're supposed to compute what is the total length of the sheet. Because in the market, we need to place the order that what size of the sheet we require and how many number of the sheets are required. So here I would like to give the again example from here. So in this case, you will see that all the sheets, they are having same width, maybe zero point 0.7. And we just need to compute out what would be the length of one sheet. And we have to check. Okay, one thing also, the maximum length which is available in the market is 4 meters. So our sheet length may be less than 4 meters. And we will need to check that whether we can cover the two panel with a maximum length of 4 meters or not. So last time I have also explained to you. So maybe I believe that last time I had one slide where I have sketched the roof sheets. If it is available, then I will explain. Yes, here. place it over here. Okay, here. So actually, I want to check whether maximum length of the sheet which is available in the market, one sheet is, can I cover two panels with one sheet or not? So, or maybe I just need to cover only one panel with one sheet, or I need to cover two panels with one sheet. So I will compute the length of the sheet. The length of the sheet will be equal to panel length. Panel length is actually, this is a horizontal distance from here to here. So if I will divide this panel length, which is horizontal distance from here to here, by this cos theta, I will have this inclined distance. So panel length divided by cos theta plus E. E is the end lab, because we need to provide the half end lab from the one side and half end lab on the other side. So n is the number of the panels. So if I'm using the n value 1, so I'm computing the length which may cover one inclined distance between one panel. If I'm using the n value 2, I'm computing the length that may be used to cover the inclined distance between two panels. So based upon this, I'm using this formula. E is the end lab that I have explained over here. Last time maybe I will be revising, because total length of the sheet is from center to center. So we are providing the half lab on the one side and half lab is covered on the other side. So total distance is from this center line, red line, to the other line is the center to center distance between panels, and plus half end lab we need to add from the one side and half on the other side. And I believe that I have already explained this last time. So we are using this formula. Width is constant, so I'm computing L1. L1 means that length of the sheet which may be used to cover one panel. So it means that in this formula, so n value will be 1, 2.5 is our panel length, divided by cos theta. I'm computing the inclined length parallel to the top chord, plus 0.2. So end lab will always be 0.2 if it is not given, because I have already explained to you that from this sheet, end lab will always be 200 millimeters. And similarly, side lab will be 1.5 corrugation or 115 millimeters. So end lab value will always be equal to 200 millimeters, if even though it is not provided. So for one panel, L1 is length of the sheet for one panel, 2.5 divided by cos 30 plus 0.2. So the length is coming out to be 3.087 meters. So I believe that you don't need to check the length required for two panels, that will be more than 4 meters. But anyhow, you may check. L2 value is 2 into 2.5, because I'm just increasing I'm using the n value 2. So I'm computing the length of the sheet required to cover two panels. So 2.5 multiplied by 2 divided by cos 30 plus 0.2. So there's a mistake here, so I will modify. So that is the two panels. So, so it's coming out to be more than 4 meters. It means that one sheet cannot be used to cover the two panels, because we do not have the length of the sheet in the market more than 4 meters. So we will use the L1 value. So we can cover only one panel with one sheet. So I told you that we always, and what length of the sheet required? 3.087, and but we will round to the multiple of 0.25 meter on the upper side. So when we are rounding, so the length of the sheet that we will purchase from the market will be 3.25 meters. Width is constant, so we will order the sheet. So sheet size will be 0.7 meter multiplied by 3.25 meters. So the length of one sheet will be 3.25, that we will place the order in the market. So rounding the L1 into the multiple of 0.25. So width is constant, which is 0.7 meter. Okay, next is we will compute the moment. Actually, we need to design this as a beam. So sheet is simply spotted. I explained within the panel length. So panel length is the, we need to consider the horizontal distance because load is acting in the gravity direction. So again, if you want, I may show with the p value. So we need to consider this horizontal distance between this panel and this panel from here to here because load is acting in downward gravity direction. If the load is acting perpendicular to the surface, then we need to consider this inclined line. So since the load is acting in gravity direction, the horizontal distance between top panel to this end panel is horizontal distance, which is referred as also panel point. So panel distance is always the horizontal distance of two consecutive top chord joints or projection of the top chord of the member. So movement will be, we are assuming steel sheet is simply supported between the panel point. So movement, maximum movement in a simply supported beam is omega L square by 8. L square is span. So span is equal to the panel length. So omega value we have already computed 762. So panel length is will be 2.5 divided by 8 because that is the maximum bending moment that may be induced in a simply supported beam. So we are having the movement of 596 Newton into meter. And then we need to compute what is the section modulus required. So I will just again explain the basic design equation. So this is the ASD. In basic design equation, allowable load effect should be equal to the capacity of the section or the capacity of the member. So I am comparing MA is the applied moment and MN will be the capacity. So nominal capacity divided by factor of safety in ASD method. So nominal capacity is equal to the Fy into section modulus, and we know that the omega value for a factor of safety in ASD we are using as a 1.67. So MA is the applied bending moment, which is M maximum over here. So I'm replacing the MA with M maximum because this is the applied bending moment. So if I divide the 1 with 1.67, so that will be equal to 0.6. So here, if we know the applied bending moment, 0.6 Fy is the allowable material stress or material strength. If we know the type of steel, so X value is the geometric property or the section modulus, which is unknown, that we can determine by this equation. So Sx will be equal to Mx divided by 0.6 Fy. So we are multiplying the movement with 1000 to convert the meter into millimeter, Newton into millimeter, because all units in this equation must be in Newton and millimeter. So M maximum 596 multiplied by 1000 and 0.6 Fy. So from this equation, we are having the required section modulus 3.98 into exponent 3. So depending upon our required section modulus, we will select the sheet from the table which is given in LRFD. So this table is also given in LRFD. So I am showing over here. So section modulus required was 3.98 into exponent 3. I will start from the bottom. So this sheet is having the section modulus less than 3.98. So this is will not satisfy. Okay, this sheet is having section modulus more than 3.98. So which is more than our required value. So I will select this sheet as a trial sheet to apply all the checks. So I will select the gauge 22 sheet from the table of 75 into 20 GI corrugated sheet. So for this gauge 20 sheet will be my first sheet that I will apply the all the checks on. And for this sheet, you need to write on what is the thickness. Thickness is 0.853. We are not concerned with the thickness. We are only concerned with the gauge value. So what is the weight? Weight of this sheet is 77.6 without laps. So 77.6 Newton per meter. Area is 923 millimeter square. Moment of inertia is 4.23 under into exponent 4 mm4, and section modulus is more than 3.98. So we have selected gauge 22 sheet, and we have written all the properties. Okay, weight of this sheet was 77.6 Newton per meter square. We will multiply this weight with 1.35 to consider the effect of the end lab and corrugation. So weight will be 105, and this weight should be less than equal to 1.2 times of the assumed weight. So this is less. So this check is okay. This means that we have already assumed the weight on the upper side. So assumed weight was more, and the actual cell weight is less. If actual cell weight is coming out to be more, so we need to revise the calculation by assuming the updated weight. Okay, next we will apply the deflection check. And I have already told you all type of the deflection check will only be checked only for live load. So we are only considering the live load for the deflection check. So the live load which was given, it was 60 kilogram per meter square. So if we are multiplying with the 1, we can convert into 60 kilogram per meter. So 60 kilogram per meter, if we are considering G value approximately maybe 10. You can also consider G value 9.81. So here I have considered the G value 10. So weight will be in Newton meter will be 600, and you can convert into Newton per millimeter by dividing it 1000. So we are using this formula. So these formulas are also given in LRFD manual. So I told you that actually the roof sheets, they are firmly connected with the boards with the purlin. So even you can consider this formula for simply spotted case, but I have considered as a partially fixed from the one end. So we are assuming that the sheet is partially fixed. So this formula we have already discussed. Maybe again, if I would like to show this formula. Yes, there. So this is the formula for simply spotted case, and this formula is one end continuous, considering this is conservative. So actually this 0.013 is equal to 5 divided by 384. So you need to assume the sheet simply spotted between kernels. So in this formula, omega L value will be used as a 0.6. P is the span of sheet, which is equal to panel length multiply power 4. So all values in this equation must be in Newton and millimeter. Whatever are the units of the E value, same must be the units of all other parameters. So E value for steel is 200,000 megapascal, or 2 into exponent 5. Moment of inertia of gauge 20 sheet is 4.23 into exponent 4, that we have picked from the table. So when we computed the maximum deflection is 27.7. And what is the allowable deflection? We have already studied allowable deflection should not be more than span divided by 90. So span is the panel length. So panel length divided by 90 is equal to 28. So maximum or actual deflection is less than allowable. So this check is okay. If this check fails, so we need to select the sheet on upper side which is having more moment of inertia. So we will use.
Excuse me, sir.
Yes.
Sir, I think slides जो हैं वो stuck हो गई हुई हैं.
आपके पास मैं स्टक हुई है नेट पे, मेरे ख्याल में मेरे पास नहीं है. All of you, ये other anybody else is having the issue in the slides? Please.
Yes, sir. Slides.
Yes, sir. Yes, sir.
Yes, sir.
नहीं भी है तो कहीं आपने एक तो नहीं किया यार, सर को बता दें स्टक हो गई है. अब कौन से स्लाइड पे हो? कैन यू सी द स्लाइड?
सर नोट्स वाली आ रही है अभी
68.
Which slide? Can you see the truss on this slide?
No sir, sir वो notes वाली जो 68 नंबर स्लाइड है ना उधर ही रुका हुआ है.
अच्छा ठीक है, मैं जरा दोबारा स्लाइड ओपन कर लेता हूँ. ठीक है, ठीक है. वो नेट पे थोड़ा सा इशू कोई, मैं उसको दोबारा शेयर करता हूँ. ठीक. हाँ जी, शेयर बताएं. नजर आ रही स्लाइड?
Yes sir. Sir 85 I think अब ओपन है. सर वो डेल्टा मैक्स वाली.
मैं दोबारा एक्सप्लेन कर देता हूँ. ठीक. Okay, I told you that we only check the deflection for live load only. We do not check deflection for total load or factor load. All type of the deflection will be checked for live load only. So we are already provided with the live load, which was 60 kilogram per meter square. And since we are considering the unit width of the sheet, so if we multiply the 60 kilogram per meter square with 1, so we will have the UDL load, which will be 60 kilogram per meter. And you can convert into maybe in Newton per meter or simply in Newton per millimeter. So because I have considered the G value as 10. So actually we are supposed to use this formula. You can also use the formula for simply supported case. In that formula, instead of 0.01, you will have 0.013. So in this formula, all parameters must be in consistent unit. Consistent means Newton and millimeter. Whatever are the unit of this E value, same must be the units of other parameters. So E value is given in megapascal. So 1 megapascal is equal to 1 Newton per millimeter square. So therefore, all values in this equation must be in Newton and millimeter. So we have converted the omega L or distributed live load into Newton per millimeter as a 0.6. So panel length 2500 millimeter power 4. E value for steel is 200,000 megapascal or 2 into power exponent 5. Moment of inertia of gauge 22 sheet we have picked from the table 4.23. Section properties table for 75 into 20 GI sheet, which is 4.23 into exponent 4. And we have computed the maximum or actual deflection due to applied load, and this deflection is 27.7. And what is the allowable deflection as per specification? Allowable deflection is span divided by 90. So span is the panel length because the sheet is spotted, simply spotted, or maybe between a panel length. So panel length divided by 90, the answer is 98. So maximum or actual deflection is less than allowable, so this check is okay. If maximum deflection or actual deflection, if it's come out to be more than 28, so we will discard that sheet and we will select the sheet on upper side, which will have more moment of inertia. So instead of gauge 22, we will apply the checks on gauge 20 because we need to meet the deflect or satisfy the deflection criteria. Okay, here last time I have already explained. So area, effective area covered by one sheet is equal to C into L minus E. So actually we are using a sheet size. Sheet size will be 3.25, just like we have calculated here. So here we have computed the length 3.25 meter and the width of the sheet will be 0.7. But actually this sheet size is not covering the whole area. Some of the edges of this sheet will be consumed to provided the end lab and side lab, just like last time I have explained from here. Because when we are using a total sheet size 0.7 meter and 3.25 meter, but some of the sheet edges or ends, they are used to provide the side lab and end lab. So it means that in that case, we need to compute the A effective or A1, effective area covered by one sheet. So we need to subtract the some end lab or side lab. So last time we have already derived this equation. So I will explain two methods. So but you can use any method either given in the book or just like I'm explaining over here. I have computed A1. A1 is the effective area covered by one sheet, which we can compute as a C. C is the cover of sheet into length of sheet minus end cover. So this is 0.858 meter. All the values are in meter. So cover of the sheet, one sheet is the length of width of the sheet minus 1.5 type of the corrugation. So 585, this value is already available in this table. So 585. So if total width of the sheet is 700 millimeter, then cover will be 585 because we need to subtract the side lab, full side, half side lab from the one side and half side lab from the other side. So 700 minus 115 will be equal to 585. So length. So here you need to use the actual length, not the rounded value. Actual length that we have computed here, maybe in this sheet, is 3.087. But anyhow, we are ordering for 3.25 because even though you are order this length, he will always charge you in the multiple of 0.25 millimeter. So we are ordering this, but actual length that we need to cover within the panel point is 0.087. So we're supposed to compute the effective area covered by one sheet, which is all values I have substituted here in meter. You can also substitute in millimeter also. So 5.585, length 3.087 minus end lap, and end lap is 200 millimeter or 0.2 meter. So effective area covered by one sheet is 1.689 meter square. So here n100, this is the first method. N100 means how many sheets. For example, if we need to cover 100 meter square area, 100 meter. So to cover a 100 meter surface area, we will divide it by the area covered by one sheet. So I'm writing as a 100 meter square divided by area of the one sheet. So I can compute the total number of the sheets required for 100 meter square area. So N100 is the sheet number of the sheets required if the total area to be covered is 100 meter. So in book, I think the calculations are given in millimeter. 10 exponent 8 is given. So 1 exponent 8 means that we are multiplying the 100 with exponent 6 to convert the meter into millimeter. So 100, if we are having 100 meter square area of the one sheet is 1.689. So to cover 100 meter square area, we require 59.2 sheets or 60. Okay, next is that what is the actual area in our case? So last time we are computing the total area on the one side, which is half length of the truss plus sheet projection and divided by cos theta. So I will explain again from here. So just assume that we are having this panel. So in this panel, what we do, so this is the end projection that we need to provide on the one side. So actually, from in this sheet, how will compute? So we are having maybe 1, 2 trusses, maybe 8, 9 trusses on the other side. So I want to compute the inclined area on the one side. Total inclined area. Total inclined area, if I know the length of the truss, half of the length from this side. If I know the half length divided by cos theta, so I will have this inclined portion. In this inclined portion, I will add the end projection. I will have the total width here. And if I multiply this width with this spacing of the truss, I will have total area covered within two trusses. So in this case, if I know the total number of trusses 8, so I will have the spacing between trusses 1 minus then the total number of trusses. So here, I believe that I have already explained this formula already in my last class. So area covered by the one side, length by 2, half of the truss sheet plus sheet projection divided by cos theta. So this will be the inclined length, and I'm multiplying with spacing of the purlin. Then I'm having the area covered between two trusses, and total area will be total number of trusses minus 1, because if the trusses will be 9, so I will have the 8 spacing. So A is the total area covered in our building or truss housing system on one side only. So this area is coming out to be 523.2 meters square. So I need to compute how many number of the sheets are required to cover this area. So we already know the total number of the sheets. N10 is the number of the sheets required in 100 meter square area. So number of the sheets required by the divided by 100, actually that is the area covered by the one sheet. And if we multiply with the total area, then N1 is the number of the sheets required on one side of looping system, that is 314. Alternative is that very easy, but there are some rounding errors, maybe rounding error of just maybe one or two sheets, but you can ignore it. So A is the total area covered on the one side, 523.3, divided by the area, effective area covered by one sheet, which is 312. So little bit rounding error is there, but anyhow the both equation or both methods are giving the same answer. Why we are having the here more answer? Because when we computed the number of the sheet required for 100 meter square, so that value was actually 59.2. So we rounded to the 60. So rounding from zero point 0.2 to the 59.2, 60 is actually providing the extra number of the sheets. But anyhow, you can still use any of the methods. So total number of sheet may be 314. So total sheet on the both side will be multiplied by 2 because we need the same number of sheet on the other side. So total we require 628 sheets for our roofing system. So next is you need to write down the design summary. So in this summary, you need to mention what gauge of the sheet is required. We require gauge 22. And what is standard designation? Standard designation is 75 into 20. And what is the sheet length? Panel size. So panel size that we need to order is 0.7. And the length will be 3.25 meter. And we need to order, we require 628 such sheets. And this is a standard spacing, J board spacing, J board at a spacing of J bolt at a spacing of 219 millimeter within the end lap and ordinary bolt at a spacing of 300 millimeter along side lap will be used. So side lap or end lap I will explain. Okay, here. This lap that we are providing here, this is side lap and this is the end lap. So I already told you that along this side lap. So this along the side, the bolt we are connecting with the bolt, and this bolt spacing should be 300 millimeter. We need to connect this side lap at a distance of 300 millimeter, and at the ends, in the ends we are also need to provide the bolt, and this bolt spacing will be maybe 1.5 time of the. I think mentioned that 1.5 time of the side lap. 1.5 time of the side lap or maybe that value is maybe 290 millimeter that we have already discussed. So it was mentioned somewhere. But this is you will use side lap corrugation with fastener. 1.5 time of the corrugated fastener placed at a maximum spacing of 300 millimeter in perpendicular direction. Along the side lap, we will connect at each 300 millimeter, and along the end, we will connect the sheet at each 219 millimeter distance. So at the end, you need to write down your summary just like this way. So at the moment, if you are having any question regarding this design of roofing system, you can ask me. So anybody is having question, please raise the hand option. Yes, Mubin Hussain, please ask the question.
सर ये जो सेल्फ वेट है अगर ये हमारा ग्रेटर आ जाता 1.2 फैक्टर से 1.2 ऑफ एज्यूम्ड वेट तो हम सर वो गेज नंबर चेंज करते हैं या वो स्टार से
no start se you need to revise the calculation. You need to revise the calculation from here. So for example, I will give you the example here. कहाँ पे था? Yes, ये वाला. अगर आपका ये वाला, if you got this weight higher, this weight, so then you will assume this weight. Okay, you will revise your calculation for the larger weight. You understand me?
सर
Yes,
स्लाइड
और सर डेड लोड
Okay.
का वेट कैसे अज्यूम करना है?
यार ये you assume this weight as 16, okay, and with 16 and this side is coming lesser and this weight is coming more, so actually this is coming from this weight, so actually you may assume this weight at the start 105, you can assume this weight. You understand
सर
me?
स्लाइड नजर नहीं आ रही जरा.
अच्छा एक मिनट अभी मैं देख लेता हूँ इसको. Let me unshare and then share me again. Okay, can you see the slides now? Slide number 84. Please respond.
Yes, sir.
Okay, see here.
Yes.
We assume this weight 16, okay? You understand me? And due to this weight, actually this, if this parameter, this factor is more, then actually why this coming, then you need to assume this weight. You understand?
Yes, sir.
Or you can consider this weight 105 and revise the calculation. Or another way is that check the, or you can apply the trial on the next section, because actually what will happen when you will change the weight, then your movement will also change and required section model will also change. So it means that the requirement of the sheet may change. It means that if the self weight checks fail, then you need to assume the larger weight. So larger weight means that you can directly assume this weight, 10.5 Newton per meter square, if this is more than this value. ठीक हो गया? You got me or not?
Yes, sir. तो सर वो स्टार्ट में जो है वो
Okay.
हम गेज 12 से गेज 24 तक जो मर्जी कर सकते हैं.
हाँ जो मर्जी कर सकते हैं, जो मर्जी कर सकते हैं. ठीक ठीक हो गया. यानी कि
थैंक यू सर.
कोई इससे अपर साइड इसको 30% इंक्रीज करके वेट अज्यूम कर लो, ठीक है, ऊपर से. ओके, जस्ट जेंटलमैन आई नीड टू, अभी मैं आपको रेज द हैंड इफ एनीवन इज हैविंग क्वेश्चन, और आई विल टेक योर क्वेश्चन इन 1 मिनट.
सर ये जो हम डिफ्लेक्शन फाइंड करते हैं ये सिर्फ लाइव लोड के लिए क्यों करते हैं?
हाँ जी, मैंने आपको एक्चुअली आई वुड लाइक टू एक्सप्लेन. Actually, whenever we are constructing the structure, you understand me? So all the deflection is already taken place due to self weight. So additional deflection will only produce due to the live load only. You understand me? So mostly when we provide the roof trusses and the purlin, sometimes we provide negative camber also. Negative camber means we provide the upward hump. So when we construct it due to self weight, all structure or the sheet, it becomes straightened, and then additional deflection will only be due to live load. So if you are also, because in normally in the concrete structure, self weight is almost 2 times of the live load in concrete, and also maybe in steel structure, so dead load is comparable to the live load. So it means that if you are also satisfying the structure for dead load also, so your structure will become highly uneconomical. So normally the most of the structure element, they are already stable due to their own weight or self weight. So it means that the additional deflection will only be due to live load. So we only check the deflection for the live load, because at the end we are comparing this deflection with the allowable limit. So maybe in AISC, allowable limits are given with reference to the live load only. If we supposed to compute the deflection with total load, then I believe that in AISC, allowable deflection limit would be different for total load. So AISC has given the allowable deflection, which was, for example, span divided by 90 with reference to the live load only. So if you are considering the dead load also, then actual deflection may be coming out to be very on the very high side, which are not realistic. Then no problem if you are having maybe the question that you have already asked me in the previous question. You can ask me again. So you got the Uzair?
Yes, sir.
Okay. Anybody else? Okay. I already have given you the data, assign you the, for example, where was so I have already assigned you this data, okay? For this task, I have given you the value and I have already specified the loads for your trust system. So actually now what I'm expecting, I don't know that what the CN University is taking, but maybe even though if they are midterm or there is no any midterm, so I'm expecting a submission, maybe in short form, maybe after maybe 2 weeks. So after 2 weeks, what I'm expecting, you are submitting a very composed report, and this report must have the panel load calculations for your truss and table of forces and purlin design. You need to design two purlin, one by assuming the channel section, and second by considering the angle section. So whichever will be the lighter one, I will let you know that which purlin you're supposed to use for your truss system. And then you need to compute the total number of the sheet or the roof sheeting design. So until 2 days, you need to complete all the tasks related with your assigned project. So I have already assigned you the trusses. So I will send you the official deadline. Maybe I will upload on MS Team. So I also supposed to give you the assignment related with the tension member design. So if someone is having any query or any question, he can ask me. Yes, Hamza Niaz, please. वो अभी नहीं, वो भी बाद में बता दूंगा, अभी ना वो मिड के बाद करेंगे, because you have already studied the tension member design, so you can start designing the member which are purely in tension, pure tension member. In your table of forces, the member which are purely in tension, you can start designing. But for the compression member, you maybe start after the completion of compression member design. But what I'm expecting within 2 weeks, but you're supposed to design the member as well. So, but you can start designing. I have already given you the instruction. Top chord and bottom chord member will be double angle, and the interior member may be any single angle, double angle, or channel. So depending upon the whichever is the lightest one. So if you are having pure tension member, so pure tension member can be designed because we have already covered tension member design. Yes. Okay, then in that case, in your table of forces, you may have some member stress reversal, but the design may be based upon tension member. You can start designing for tension, and later you can check the capacity for compression. You understand me? And all the members which are stress reversal based upon the compressive load, you can design after the completion of compression member design. You understand me? Anyhow, yes, yes, please ask. No, 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 no. Not 20. Only just design for the continuous member. You understand me? Adjoining member, not to the all. At the moment, just design for their load value. I will explain it later. Consider design every member as an individual member. Then I will explain later. Okay. Anybody else?
सर वो जो डबल एंगल मेंबर्स होंगे वो वेल्ड से करने हैं तो उसमें स्पेसिंग 0 कंसीडर करेंगे ना इसकी वैल्यू?
नहीं 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 नहीं, no spacing. We supposed to use the stay plate and gutter plate. You understand me? Gutter plate, because we are connecting the double angle at the end with the gutter plate. So if you are using double angle, gutter plate will be within the member. Spacing will be 10 millimeter. Okay.
Yes sir.
How we can connect with the gutter plate? You understand?
Okay, okay
yes.
sir.
और
sir,
क्या question?
का क्या हिसाब किताब है कि
I
पेपर्स?
do not know because at the whenever the policy will be announced, So student will be informed accordingly. Okay. So at the moment, what is the previous policy that will prevail? But I don't know how the university is going to decide. So I believe that university will take the decision within 1 and 2 days, by Friday maybe. So our higher authority, they are considering all the options. So whenever they are making certain policy, so it will be announced and it will be shared with the student as well. So at the moment, I cannot comment on it.
Okay,
Understand?
sir.
Okay. Anybody else is having question? So, gentlemen, actually, you are lucky maybe because I wanted to start the next topic connection, but I have to attend a meeting at the moment. So I will stop here and I will conclude the lecture. So actually, if there is any midterm, then you are expecting one question from your lab part also. So you may have at least 10 marks question from this design part. Design part means that you may expect question maybe from the panel load calculation, maybe from the purlin design or from the roof sheet design. So one question will be from tension member and maybe 10 marks question will be from compression member. Yes, Uzair, what is the question? Uzair, yes.
सर ये जो हमारा डिजाइन पार्ट में से मिड टर्म में आएगा क्वेश्चन, सर ये एक्स्ट्रा इसके मार्क्स होंगे या ये उसी 30 नंबर में इंक्लूड होगा?
No, that will be included in theory. Actually, the theory part is very long. So we are covering most of the theory part in design classes. So this is the design class. This is not the lab part. So we are teaching some theory contents in our design part. So that will be contributed toward the theory. You understand me?
यस सर. तो सर लैब की फिर ग्रेडिंग जो है वो किस बेस पे
Yes,
होगी?
lab
इसके लिए अलग से?
evaluation. Yes, lab evaluation will be based upon your design report that you will submit at the design of the roof truss system. You will prepare a drawing sheet for the truss that you have already designed, and there will be quiz. So they most probably,
Okay,
if
sir.
you might have only one quiz maybe now at the moment. But if you are coming after the midterm, then you will have two quiz. So quiz marks will be at least 40%. So you will have 40% quiz marks, 40% your design project, and 20% will be your viva. That will be the 100% weightage from the design classes.
Okay, sir. Thank you.
Okay. Okay. So if you are not having any question, then I would like to conclude the lecture. So you can send me your queries on MS Team also. So I will answer at my available time. So inshallah, see you the next time. Allah Hafiz.